Okay, so we're going to look at, ladies and gentlemen, hypotenuse-Lake theorem and side angle side. Side angle side, if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Hypotenuse-Lake theorem, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. Notice that side angle side is a postulate, which means we can't prove it, but hypotenuse-Lake theorem is a theorem, so we can. All right, so let's look at this lovely proof. We've got the diagram. So what out of this diagram do I have? I know side AC is congruent to what? G. I also know that angle C is congruent to what angle? G. And I know angle side CB is congruent to? And those are all given. So now what do I have? I have that the two triangles are congruent by what? There we go. All right. Let's turn it over and look at this other lovely proof. Side angle side. The two triangles are congruent to each other? From where it says prove? Okay, so we've got this lovely diagram. So I'm going to state what I've gotten from this diagram. I know that side AB is congruent to DC, and I also know that AB is parallel to DC. And I'm going to call this the given. Okay, so I've got a side, so I'm probably going to need another side and an angle in between them. How would I find the angle in, well, what other side do I already have? Look at these two triangles. What side do I have? BD. BD is congruent to BD by what? Good. Okay. Now we've got the side in the middle and the side up and down. So I need angle B, angle ABD, to be congruent to angle BDC. How would I know that those two angles are congruent to each other? We know those two sides are parallel. BD would make transversal. Yes, Eric?
A alternate material.
Alternate material. Now do I have a side, an angle, and a side? So now I can say that triangle ABD is congruent to triangle CDB by side, angle, side. Excuse me?
Is that
ABD to CDB. All right. This one is very, very long, and I think I have one typed up, so you'll have to give me 1 second. Hold on 1 second. I want to say I have a hypotenuse leg theorem already written out. Maybe not. I thought I did. Do I have one that says done? Okay, oh well. I thought I had one nicely typed up, but I don't, so we'll just go through it. Okay, so I'm going to do some stuff with this one that you might not particularly love. Okay, so we've got hypotenuse-Lake theorem. And hypotenuse-Lake theorem, to prove it, there are multiple ways to prove it, but one way that we like to prove it is with drawing it out. Sorry.
That's cool.
Okay. So let's see. I think I have a good. All right. So one of the reasons a lot of people don't like this is I'm going to do some crazy drawing in here. First thing I'm going to say is angle ACB is a right angle. That's given. So let's draw it in. ACB is a right angle. Next, I'm going to say angle XZY is a right angle. And that's given. Now I'm going to do this crazy thing where I'm going to draw in another triangle. Okay? When I draw in another triangle, I know that XZ is perpendicular to YW by the definition of perpendicular lines. Okay? So that proves that angle XZW is a right angle. Hold on 1 second. Let me write this theorem down. This is the whole, if two lines are perpendicular, then there are four right angles. Yes?
Is W supposed to be connected to C, or is it just supposed to be like?
It's not supposed to be connected to Z. It's the exact reflection of the other triangle. Yes?
For number 4, what is the reason?
If two lines are perpendicular, then there are four right angles.
Is there a way we can shorten that?
I think it's postulate something in your book, but I don't have the numbers memorized.
Hypotenuse leg or no?
Huh?
Hypotenuse leg.
No.
2 lines are perpendicular.
It's a postulate. Two lines are perpendicular, they form four right angles. Yeah. Okay. You can look that up. Angle ACB is then congruent to XZW because if two angles are right angles are congruent to each other, we call that right angle congruence. I'm going to shorten that by saying, here's an angle, here's the R in it, right angle congruence. Everybody get that? Now I'm going to say that AC is congruent to XZ by given. Okay, I know we've done a lot of stuff without using that given, but now it's going to be important. So that's why we didn't use the given all at the beginning. And now it's going to be ridiculously stupid and not let me. Don't do this, please. I don't want to start all over. And it's going to make me, okay, fun. Alright, I'm going to just go where we started off, left off from, which is 7. Hopefully you got that first part copied down. If not, your partner does at your table. So W, and you can always watch this again on my blog spot if you missed it. BC is congruent to WZ, and this is given by drawing, we'll call it, or construction. Then we therefore know that triangle ABC is congruent to triangle XWZ by side, angle, side. And then we know XW is congruent to AB, and we call this corresponding parts of congruent triangles are congruent, which just means exactly what your extra credit question was. If the triangles are congruent, all their sides and angles must be congruent to each other.
What's the reason for number 9?
Corresponding parts of congruent triangles are congruent. If the triangles are congruent to each other, all the parts must be congruent, right? That makes sense, yeah?
Yes.
Okay.
Ja.
Yeah.
All right, thank you. 10. AB is congruent to XY. This is by given. XW is congruent to AB. Oh, I skipped one. Sorry. That's why you shouldn't be doing independent math. Should be XW is congruent to XY by transitive. Angle XYZ is congruent to angle XWZ. Okay, this is by something really, it looks really weird. Two sides
What is
of a
that?
triangle are congruent, then the angles opposite are congruent.
What's number 9's reason?
Corresponding parts of congruent triangles are congruent. Okay? Then we've got angle WZX is congruent to angle YZX by right angles congruent. And then triangle WXZ is congruent to triangle XYZ by angle, side congruency. Therefore, please don't talk while I'm talking. Triangle ABC is congruent to triangle XYZ by transitive. And we are finally done. All right. No, I will not expect you to repeat this on a test or quiz.
Oh,
No.
God.
But this is really important that you have this written down because it does prove a theorem. It is important because it says flat out on the state standards and things like your ACT, MME stuff that you have seen the proof of the hypotenuse like there.